Hey kids, it's Dr. Runs here with Objective 33, your favorite and mine. We are going to write multi-steppers to go along with real life situations. Real life situation is math teacher code word for word problems. Yep, we all love them. And we're going to struggle through them together. It's going to be great. Not nearly as bad as the reputation that word problems have. But before we get started, just know that I do my very best job to give you a good, concise rundown of the lesson that you may have missed or forgotten, but it's not going to be perfect. And of course, different teachers or adults might explain this differently, and that's totally okay. This is just to help students be refreshed on things they may have forgotten or serve as help for students who have missed parts of class. So away we go. When we're writing an equation, we have to make sure that this equal sign is to show that one thing is equal in value to another thing. So for example, if you are talking about a single dollar, how many quarters make up that dollar? Well, 4. Okay. You can't say 6 quarters, 10 quarters, -7 quarters equal a dollar. It's only 4 quarters that are equal to a dollar. Similarly, 4 quarters only equal a dollar, not $10, not $20, not $1 million. It's only $1 that 4 quarters are equal to. So make sure that this equal sign, you keep that in mind, that it truly means equal in value. Now, specific to word problems, and this is coming from a lot of experience in watching 8th graders sometimes struggle. Please make sure that you actually read the situation carefully. Oftentimes students see words and they think, oh, I'm out. Please actually attempt to read the situation very carefully, and then, once you're done with that, read it again. Sometimes you have to read a word problem multiple times before you thoroughly understand it. The elementary schools teach 4 times through reading through a word problem. Again, making the point that you may have to read this several times. You can underline key information to help you focus on what you really need. You can take little brief notes on the side to, again, keep track of important information. And you can also illustrate it. Those of you who are not Picassos, not artistically inclined, I'm right there with you. But we can make stick figures look good together. Don't underestimate a good stick figure. All right, after you've solved the problem, make sure you understand what the number means. That will help you choose an appropriate label. Ask yourself, does the number make sense? So if I do a word problem and ask you how many people will fit into a Ford Focus and you come up with 8.5, that doesn't make sense. You can put a half person in a car, but you shouldn't. That answer doesn't make sense. Like -3 wouldn't make sense. You can't put negative people into a car. So make sure your answer makes sense, and then determine what the label is. And make sure it's complete. All right, in class, we did an activity where we sorted several words that are characteristic of different operations. So I'd like to share that with you. We're not going to draw it out, but you should, of course, put this in your notes, perhaps pause and write this out, but I'll just read through this pretty quickly here. Addition words are some, more than, increase by, longer, bigger, faster. They're longer is kind of a summarizing all the words that are referring to bigger. Subtraction is difference, less, decrease by, diminish by. This less than is a word you have to be careful that oftentimes changes the order. We'll have an example of that later in this lesson. I can point that out to you. Multiplication is product of, is a multiplication word. It's tricky for kids to remember, but it's the most common one. Times, and then twice, not just multiplication, but it refers to times 2. For division, quotient, or you use division when you're determining how many times bigger one thing is than another. And we did this with our scientific notation unit as well. It's confusing for students because the word times is in it, but you're determining how many times bigger something is than another or smaller, and so you have to use the inverse operation to find that solution. Equals is, or sometimes are. The variable is the thing that you're trying to find. It can be the word what, or it could be a number. So this is something to have on hand as we are going through our notes and the homework to help you along. Okay, so we will start with some simple questions and then go on to some slightly more difficult ones. I wanted to show you that sometimes you can just follow the order of the statement and write in the words or the numbers or symbols that go along with them and then end up with your equation. This says 7 more than 3 times a number is 31. And we're going to find that number. And of course you could manipulate numbers and you can come to your own conclusion eventually your own way, but it is a little bit easier to know how to do this algebraically. So there's 7. More than is addition. 3 times is a multiplication word. A number, yep, that's x, is equals 31. And when we do that, we've just created an equation for ourselves. Now sometimes it's a little bit complex for students to have that so spread out, so you can condense it. You don't need 3 times x, you can just do 3x if that's easier for you. And when you write it like that, you can say, oh yeah, I totally know what I'm doing. Solving for x, subtract the 7, 3x is 24, and of course divide by 3 to get 8. 7 more than 3 times 8 is 31. 3 times 8 is 24, 7 more than that, yep, that's 31. Our mystery number is 8. There's not much of a label that we can put with that, so we would call that one done. All right, flip over and let's look at some other examples that we can do. Okay, we have 3/8 of a number decreased by 1 is 5. And again, we're going to find the number. This here, this hyphenated thing, refers to a fraction. So 3/8 is referring to 3/8 like this of a number decreased by is a subtraction is 5. 3/8 of a number decreased by, I didn't get the 1 in there, equals 5. Oh, well when you write it like that, it makes so much more sense. 3/8 of that same number is also 6, multiplied by the reciprocal. So x equals 16, because 6 times 8 is 48, divided by 3 is 16. 3/8 of 16, so 1/8 is 2, 3 of them is 6. 6 decreased by 1, yep, that's 5. Our answer makes sense. And so I can circle it up. So again, just to show that this doesn't have to be so difficult, you can oftentimes just follow the order of the word problem to get your equation. Okay, so let's add a little bit more content to our word problems here. Okay. The Nile River is 6,690 kilometers long. This is 394 kilometers longer than the Amazon River. How long is the Amazon River? Now, of course, you could very likely find this without using any equation at all. I'm using a basic situation to teach an equation that you could use in a more complex situation. Now, what I recommend here is you first identify the two things that you are comparing. So we have the Nile and we have the Amazon. So what I'd like to do is to write Nile and Amazon. So I can put the Nile information under Nile, Amazon information underneath Amazon. And they'll be separated by an equal sign. Okay, so the Nile River is 6,690 kilometers. There's no more information for the Nile. This is This is 394 kilometers longer as an addition word, than the Amazon. Do I know the Amazon? No, because I'm trying to find it, right? So it's x. And now I have an equation. 6,690 is 394 and x. The reverse of positive 394 is a negative 394. To get 6,296 is x. Or we know to write the variable first. Great. Now several of you probably already figured that out before you even did an equation, but again, the point is to teach you how to do a more complicated situation. Now, we need to stop and make sure that our solution makes sense. First of all, what is this number? The number of Amazon rivers? How many fish are swimming in the Nile? Like, what is this? Oh, this is the length of the Amazon River. So we can say the Amazon River is, and by writing this, it tells me that you know the length of that this is the Amazon, not the Nile River, right? Is 6,296 what? Yeah, kilometers. Or you could just do km. Wide? Deep? No, long. Great, and that would be a good answer. I could take out this x equals. The Amazon River is 6,296 kilometers long. Great, and that makes sense, and it's logical too, right? And get a negative number, didn't get a tiny number like 5. Okay, yeah, the Amazon is big. 6,296 is also big. Okay, great. Let's try another one. The fastest, sorry, gotta fix my tripod thing. There we go. All right, the fastest speed recorded for a cheetah is 70 miles per hour. This is 11 miles per hour, less than 3 times the fastest running speed of man. What is the fastest running speed for a man? Okay, first of all, I'm going to mark this because this is going to be that potentially problematic phrase, less than, that sometimes changes the order. Now you may be having a hard time kind of making sense of 11 miles less than 3 times the fastest running speed of a man. So again, I recommend that you find the two things that you're contrasting, the cheetah and the man, separated by an equal sign. You could draw them out if you want to. Grrr. It's running. And my man. He's scared. Okay. Anyway, that's just for fun. Let's see. Cheetah is 70 miles per hour. This is 11 miles per hour, less than 3 times the fastest running speed of a man. So 11 less than is a subtraction word, but 11 needs to be less than something else, right? If I said I have $5 less than you, I would need to know how much money you have to determine how much money I have. So this 11 miles per hour less than is an order changer. The negative 11 actually comes in the end, and it's less than 3 times the running speed of a man, which is what we are trying to find. There we go. So 70 is 3x minus 11. Add up the 11 to get 81 is 3x. Divide by 3 to get 27 is x, or x is 27. But what does that mean? What were we trying to find? The fastest running speed of a man. The fastest running speed of a man not ideal how I wrote that out, but It works. The fastest running speed of a man is, don't need this anymore, 27, is it kilometers or miles? Miles per hour. And then, is it logical? 27's fast, but it is the fastest guy who can run. I suppose I've been in a car going about 30 miles an hour. That'd be fast, but he could do it, right? Okay, but it's not like 82 or negative 27. Those would not make sense. All right, let's do one more. I'm gonna reconfigure here. Okay, so the Empire State Building is 1,250 feet tall. This is 140 feet more than twice the height of the Washington Monument. So how tall is the Washington Monument? So we're comparing Empire State Building and the Washington. Empire and Washington. All right, and they're separated by an equal sign. So which one's bigger? This is Empire's bigger. And it's, so here's the Washington Monument. It's the one from Forrest Gump. Well, you guys don't know Forrest Gump, you're too young. But anyway, it's twice the size of that. And then some, 140. So it's big, big. I mean, Washington Monument's big too, but okay. So this is actually 1,250. This is 140 feet more. So this little bit is 140. Then twice the height of the monument, which is our unknown. There's two of those and a little bit more. More than two of our unknowns, okay, which makes sense. This whole 1,250 here is twice of the monument and 140 more. Okay, sometimes drawing it out is helpful. Sometimes it just makes things more confusing, so don't do it then. All right, so two monuments are 1,110. So I ended up with 555 equals x, or x equals 555. It's a fun number, but what does it mean? What am I trying to solve? The Washington Monument's height. The Washington Monument is 555 what? Feet tall. Good. And again, it's nice for you to put which thing that you were solving for in here so that we know that you know what your solution is. Okay, so hopefully you can see that this is not so difficult as one might think. So here's your homework, and it's based off of the notes. Again, there's two short word problems and three that are a little bit longer. I recommend that you use your notes, this bank of words, to help you. If you didn't write them down, perhaps take a screenshot of them right now. That'd be helpful. Okay. Because you will see those same phrases used in your word problems, diminished by. That's not used very commonly, so you might want to go back and look that one up. When you're doing the next ones, you need to determine what are the things that you're contrasting. So this one's talking about an apple and a banana. So you'll need to put apple information on one side and banana information on the other. This one's talking about width and length and so forth. And I think that will help you a lot. When you're done, make sure that your solution makes sense, and also make sure that you do a full and complete label. Okay, sometimes real life situations are tough. You might need a little extra help. Please do not hesitate to send me an email here. And I'll get right back to you as quick as I can. Or, of course, you know that you can find me at school. Thanks a bunch, guys, and I'll see you later.